to you, Suhas. Thank you.
Yeah, thanks, Chris, and thanks everyone for joining. It's nice to have you all here. So let's start. Before we start, I just wanted to give a quick intro about myself. So I'm, as Chris mentioned, I'm the CTO and co-founder of Hudson Labs, and I have been working on LLMs and NLP for a long time. I first started working on it in 2010, and went through several AI winters and summers. So I am also currently at the verge of completing a book on LLMs called Designing LLM Applications, which is being published by O'Reilly. I'm also quite active in the open source space and have been involved in many um, teams that built open source language models, including being a co-lead of Bloom, which at its time was the world's largest multilingual model. Um, so just a quick intro to Hudson Labs. So many of you already are well aware of what Hudson Labs does, but for those who aren't, so we started in 2019 as a financial AI research team. We have been working on adapting language models to the financial context. So domain adapted models, and our customers include asset managers from places as like London, New York, Toronto, etc. So uh, the features using our domain adapted models, we have built dozens of features over the last few years, including features that facilitate idea generation, news feeds, um, earnings transcript summaries, background memos for companies, and so on. So getting right into the talk. So this is some work that we did earlier in the year at Hudson Labs. There is a post about it if you want to look at it in detail on our website, where we knew that there is a lot of hype about AI, and we wanted to quantify it. So we looked at the number of analyst questions that were received by US public companies during earnings calls. And as you can see over the years, after 2022, there was a massive jump, and that the pace of increase is not slowing at all. And now that we are starting with another hype cycle, which is about LLM-driven AI agents, this is bound to increase even further. So why this particular talk? So we have been receiving a lot of questions from our customers, from investors, from practitioners in the industry, asking what would questions about the feasibility of AI agents. How does 2025 look like? How does agentic AI, how will agentic AI impact the world of finance and capital markets and so on? So this talk is in response to those questions, and I hope we give you enough context to help separate the signal from the noise, because there's also a lot of the hype around there, which also brings in a lot of noise. So just an agenda of how we are going to spend the next 45 minutes. I'll give a very short primer on LLM basics to those who are not familiar with it, and then I'll talk about what LLM-driven agents look for, in the world of finance. Then I'll talk a little bit about the in-house research that we have done at Hudson Labs, and the things that we have find that works well for us, and also try to talk about how certain approaches that are commonplace right now in the industry are probably worth questioning, or probably taken with a grain of salt. And then finally, we'll talk about how these agentic solutions will impact Hudson Labs products going into the future. So LLM basics, a very quick primer. So language models like ChatGPT or Gemini or Claude, they are trained on a humongous amount of internet text, not just internet text, but it could be books and uh, a whole all other bodies of text that is available to them, um, and they are trained effectively to predict the next token in a sequence. And just that simple training procedure um, over a very large scale um, provides the model with understanding of the grammar of the language, but also not just the grammar, but also the meaning behind it. So just to give a very quick example, let's say that our training data set contains a book, and that book contains a sentence that looks something like this. He took the umbrella to the restaurant. And we asked the language model during training, predict um, this word. And there are so many valid continuations. It could be restaurant, it could be, school, and a lot of different nouns and places, etc. But what it definitely is not is, the word is, because that would break the rules of the English language. But if this happens at scale, after it looks at millions and billions of such instances, it'll know that, you know, you can't have the word is after the word the, and thus, it starts learning the rules of the English language, which, back in the day when GPT-2, one of the earlier language models came out, you could see that it was pretty good at English, but it was not understanding meaning. But as language models get larger and larger and they train on more and more data and larger sequences as well, the language model starts absorbing even more complex concepts. Um, so the evolution of language models. So this is one of the, I guess, in the history of technology, probably one of the um, the fastest adoption cycles ever, because this was 2018 when the modern language models first made their. There were other types of language models back in the day, but the first modern language model would be around 2018. Just a year later, our company started, and we started researching on language models. And you can see that this year, RAG, and as many of you have heard about, which is language models being able to uh, work with your data, with your knowledge sources to give you answers to questions. That is going mainstream. And now everyone's question is, are agents going to go mainstream in 2025? And we'll try to answer that question. So before we dive deeper into it, I want to talk about what agents are specifically, because the meaning of the word agent is already being expanded, because everyone wants to say we are working on agents. Therefore, in the last few months, we have noticed that things that are typically not called as agents are being called as agents, just because everyone wants to get into the bandwagon. But agents do have a very specific, I guess, definition, because it does make a difference here. So, for example, what we define as agents is they are LLM-driven software systems that take autonomous actions and interact with their environment. This part is very important, the word autonomous. That means for the first time ever, we have systems that we are not telling them exactly what and how to do. We have these agents that can take actions without us telling them to take that specific action. And they can interact with their environment. The interaction with their environment can take place in many different ways. So for example, it can fetch data from a database, or it can call a calculator app to calculate something, or it can run a computer program. All of those and the decisions to do those actions could happen without an explicit human or a computer program asking them to do it. So the implication of this definition is that agents could potentially, ideally, solve a task without it being necessary to specify how to solve it. Now, there are many, agentic solutions where it doesn't hurt if you give it clues on how to solve a problem, if you know what kind of problems it is being asked to solve. So this part of the definition is not very strict, but this part is. So given this, let's look at how the current models behave when faced with questions that require these multiple steps in order to come up with an answer. And we'll look at it from the lens of finance. So when ChatGPT came out, we prepared a test data set and to evaluate the capabilities of language models. And one of the questions in that that we share with the public is this question: who was the CFO of Apple during the time when Apple stock price was at its lowest in the last 10 years? So now this is a question. This particular question may not be very interesting, but this type of question is what a lot of analysts would like to ask. This type of question that involves fetching data from multiple sources, doing some kind of calculation, and so on. So the question that I have, and I'm very curious to hear from you all, is: can currently available tools solve this task without human intervention? And let's assume that all the data that it needs to solve this task is available to it. All it needs is to fetch that data, interpret it, aggregate it, and come up with an answer. So how many of you think that the current models and tools that are available are able to solve this? And I'll give you a little while to come up with the answer.
There's a poll
yeah.
in case you missed it. It should be popping up on your screen.
Yeah. Okay. Are we ready to proceed?
Yeah, it looks like the vast majority of people either say more or less, or we're not there yet. We have a much more bearish audience than the VCs.
Yes. we had a similar presentation with the VCs, and no one said it cannot be done. Everyone was very optimistic. So yeah, so this looks more or less in tune with the rest of the talks that I have given. So okay, so let's look at what does it take to solve this task. So that you need to break down this task into several subtasks. So what does that mean? First, you need to find the current date. The current date can be either provided in the prompt, or you can fetch it from the operating system or from the web. And then it needs to calculate the date range. So in this case, the date range is today minus last 10 years. And then it needs to query a database to find the date where minimum stock price of Apple. And then it needs to query either the web or the financial knowledge base to find the tenure of the Apple CFO. And then it needs to use arithmetic reasoning to match the tenure with the date of the least stock price. So let's see what the current publicly available generalist models do on this kind of task. So this test, we performed it in April 2024 for the full version of the test. I did check yesterday to see if any of the models have suddenly changed their performance on that, but it looks like everything else still looks like the same. So the correct answer is, the lowest stock price is between $20. Happened May 2014, with Peter Oppenheimer being the CEO. One note is that this CFO, resigned later in the year. So, but at this time he was the CFO. So let's see who gets it right. So Perplexity Pro with GPT-4o backend. So this is supposed to be the state of the art, and it comes with an incorrect answer. It says Luca Maestri, but then on the other hand, it says Oppenheimer here, so it gives two answers, and it fails. So, but whenever we, whenever we see something, wrong coming from the language model, people just say, "Hey, you should just prompt better, bro." So we used advanced prompting, which is also called cheating, and I'll elaborate on why it's cheating later. But after elaborate prompting, we come to this. It says that even though it says, somewhere here, Oppenheimer was the CFO is Oppenheimer. It gets the final answer correct, but it was just guessing because it gets the stock price wrong. Because the stock price was $20, but it says it's 164. And then we try, Gemini 1 Pro 1.5 long context, and then it tries to argue with me that, oh, May 14 is the date of the when the stock price was its lowest, but it's beyond the 10-year window between April 30 to April 30, 2024, even though it's not the case. And then it kept arguing with me for 20 minutes, saying it's unusual for a stock's lowest price in 10 years to be so close to the start date, which shows that it has a pretty weak opinion of the US economy. So, conclusion, that does this mean that AI is not yet there? Actually, it doesn't. What it shows is currently that generalist models that are not very specifically tuned for finance, they struggle with these even relatively basic questions. But the technology does in fact exist to solve these kind of questions at least. But for that, you need specialized and directed workflows to be built. And the way to go forward is smaller open source models that are working in tandem. So when I was giving this talks about agents in 2023, I presented a very bearish opinion on them. I would say, these are the reasons why agents could not be built, and there needs to be these technical advances in order for agents to be feasible. But in the last few months, I think those technological advances have come. And it's not because the larger models got better. It's more that the smaller models, that is Llama 3 by Meta or Phi 3 by Microsoft, etc., have gotten a lot better than they used to be for models at that size. And now you can use those models a lot, performing various different tasks in a particular agentic workflow in order to solve your task. And we'll talk more about that later. But the question here again is, why didn't these models, succeed? What happened? And the so in order to answer this question, one thing that we spend a lot of time on at Hudson Labs is model evaluation, figuring out what are the limits of the capabilities of models, especially when it comes to reasoning, when it comes to things like common sense reasoning, etc., which is currently the Achilles heel of large language models. So we prepared, a data set for that, and I'll talk about that later. But the key question that we want to answer is, are language models, are they generalizing? Are they, or are they actually just memorizing what they have seen in the training data, and how can we tell? And our test set tries to find that. So you may have seen, in media, things like GPT-4 beats 90% of lawyers. So this is true. This is not fake news. It actually does manage to beat lawyers, pass the bar, etc. But that is because a large number of questions that appear in those exams, or similar questions to it, have already been in the training set. So it's memorizing, or it is fetching similar exam questions that it has seen before. This also, brings the question, maybe these exams, be it the CFA or the bar exams, they are not really testing the real thing, because if it's so easy for a language model to pass it just by training on similar data sets, then maybe they need to rethink the quality of those exams. But let's talk a little bit about the test sets that we prepared, and I want to give an example of that. So in this case, this is a street grid. For people from the city of Toronto, you can identify this. So it's made up of streets that go from north to south and from west to east. And there's things like Dundas Street, Queen Street, King Street, Wellington Street, and so on. So what I do for this particular test is I interchange the names of the streets. So it's no longer like Dundas and Queen. Instead, it's like Queen, Wellington, Dundas, King, and so on. So I interchange the names of the streets, and then I ask it, give me directions to go from point A to point B. So why am I interchanging it? So because the language model has already been trained on a large number of directions related data. So for example, there are websites which say this restaurant is 2 blocks north of King Street and 3 blocks east of Church Street, and so on. So there's so much directions data that it can just refer to its training and its internal memory, and then give you the answer. So what we want to test here is, if we interchange the names, will it be still able to give directions? So again, I'm curious to hear, can the best LLMs here give directions in a city grid that wasn't part of its training set?
So far, no one thinks that AI can give directions seamlessly in a city grid that wasn't part of its training data set.
Okay. So it is correct, yes. So far, even the most state-of-the-art models were not able to give the correct directions. They would fail. And to give some context, so our test set contains 100 questions in reasoning, and today's best models get only 12 out of 100. So it's pretty clear that language models today have a reasoning limitation. So that means they are not intelligent in the way that humans are. Even though they are able to perform tasks, they can perform tasks when you could approximate reasoning in some particular way, or if reasoning is provided through some external means. So again, over-reliance on model reasoning is one of the reasons that these systems fail. So that is currently the biggest limitation, as we notice in our test set. So we'll now talk about the work that we have done in-house over the years to make things work, and things that we noticed, because there are a lot of failed experiments as well, but the experiments, during the course of our experiments, we noticed that these are the ones that actually work. So one of them is the importance, when we are working in finance, the importance of language and vocabulary design, because financial text is very different from general purpose text that is available on the internet. So GPT-4, of course, it's trained on all these generalist language models. They are trained on financial news, etc., but it's just comprised a very small part of the data set. Their larger data set is made up of all general purpose text, not very that doesn't have that the linguistic characteristics of financial text. Financial text is interspersed with numbers. It has a lot of this jargon, legalese, etc. So for example, look at how GPT-4 processes the word EBITDA. There is no word in GPT's vocabulary called EBITDA. So that's why it doesn't process it as a single word, but it actually processes it at EB, IT, and DA. So in practice, because the word EBITDA occurs in a lot of documents, and GPT-4 sees that these three subwords occur together, it has a little bit of, there's some signal that is captured in that, but it's much less efficient than having EBITDA as a single word, which is what we notice, finance specific language models would, have words, have, they're called tokens for people who are um, more technically involved in this topic. So in this case, having EBITDA as a single word would allow it to give the strength to represent the meaning behind the word EBITDA. Similarly for goodwill impairment. So GPT-4 breaks it into good and then will and then impairment. But all of these subwords have different meanings in English. But if a finance specific model, we would, just use goodwill impairment, a full phrase as a single token, as a single word, so that it can itself represent the meaning, the concept behind the word goodwill impairment. So that's one aspect of vocabulary design. The other aspect is about how we think about language as a whole. And this is some work that we have done internally, and we see very exciting results. So language models currently have a dual purpose. So they are used to model language, which is a vehicle for your thoughts, feelings, and statements, etc. And also they are also used to model the underlying phenomena that led to the construction of text in that language. But you don't need to do this together. So maybe what if you separate out the language learning from the concept learning? And the concepts could be things like reasoning, finance, law, mathematics, and so on. Can you do that? And we wanted to see how it would look if you separate the language part from the concept learning part. And to that end, we trained a couple of language models from scratch. One called a chess LLM, which is trained on 20 million publicly available chess games that are written in the portable game notation. And this is how the game notation looks like for chess. So we didn't train it on anything else except just the games, and a lot of games from scratch. The resulting model was able to actually know the rules of the game, even though it was never explicitly stated to it. And it could actually win some games, even though it was not a spectacular player by any means, but it could actually win a fair amount of games, and play like a beginner, or which is really fascinating. So then we trained another model. It's trained on the same number of games, but this time we train it using English language description of the moves. So we train it like white moved pawn to e4, black moved rook to d2, and so on. And what is the resulting language model? Even though it is trained on the same number of games, it performs much less, performs much worse than this model, and it doesn't even understand the rules of the game. So what's happening here? So language by itself is inefficient, it's redundant. It primarily exists for facilitate a social function. It's inherently social in nature. But language models, they are not social. You don't necessarily need to teach things to them in language, in human language. Therefore, that's where things like this notation helps vastly in teaching chess than the English version. Similarly, think about that for finance. Imagine we have a domain-specific financial language, and then instead of training financial concepts in English, we use the domain-specific notation and then bring the language model to a CFA level. And that's part of what we are working on right now. So the other part that that we came up with and we have seen have a lot of impact is getting the right context. So for example, in a annual report, page 5 says all numbers in this document are represented in millions. And then page 123 says capital expenditures increased by $23. So now if I ask a question, tell me something about capital expenditures, the model will retrieve this part of the document, and then it'll look at, okay, $23, but it doesn't know this because it's so far apart. And especially there are long context models today where you can put a 150-page PDF, but in this case it need not be just about one PDF. It could be among thousands of PDFs. I need to capture the answer, and it's impossible to have both of these be part of the retrieved context for the model to provide an answer. So we have a proprietary algorithm called topic spans, which takes these assertions as rules and then applies the rules to all parts of the document, that combines these rules that for which these rules are relevant, and thus at that time you will be able to get both of these in the same context. So now just talking about what we have done that helps us achieve better results over the years, especially from a finance specific context. One is domain specific language models, training on SEC filings so that it can be exposed to the type of boilerplate text that SEC filings often have, the legalese, the jargon, etc. Also, just like I mentioned above, it's not a single model, but a lot of models working together in tandem, each of them having a different role. So, for example, our background memos are generated in a 31-step pipeline involving 6 different models. And the reason why we need that, and over time, it would change because as the finance specific models or generalist models, as they get better, we can reduce parts of that pipeline. But as of now, due to all the limitations that we have in reasoning, etc., you need such a large pipeline to take care to plug in the gaps everywhere. We also do noise suppression, as I mentioned, which is figuring out what is boilerplate in SEC filings, for example, relevance ranking, which is ranking in terms of importance based on a particular criteria. We use non-English special tokens to direct control flow so that this kind of task breakdown can happen seamlessly without the model getting stuck at one of these spots. So now we want to share some experiences on what doesn't work, and
the fun part.
Yeah, things that we noticed that are being talked about in the industry a lot, but even after extensive experimenting, we found that it just doesn't work. One of them is just advanced prompting techniques. For those who are technically involved in this, things like React, reflection, and all of those other advanced chain of thought techniques. And whenever, as I said, LLMs don't give the right answer, people just say better prompt. It's a skill issue, just prompt better, bro. And remember, I said better prompting is just cheating. and this is the reason why. So as an example, I know my friend who uses ChatGPT to pick stocks, and he actually does pretty well. And he was completely convinced that ChatGPT is, this genius who is helping him out, make a lot of money. And I was curious, and I asked him, can you show me your prompt? And then he shared it with me. And when I looked at it prompt, it was so elaborate. It had so many clues because he already had an idea of which companies he wanted to. So he is putting in so many clues and tips in the prompt that for the language model, it doesn't need to do any reasoning to come up with the list of companies. It's just a lookup problem. So in that case, it was a very egregious example, but in many cases, you would see that the prompts, there is leakage. There is a leakage of and it's very subtle, and people don't realize it. That the knowledge that they have about the answer gets leaked into the prompt. And but when you have a system that it's into the wild, it's in the wild, and you don't know what kind of queries you are going to ask next to the model, this becomes infeasible. The other thing is multi-agent architectures, where this is all the rage right now, where you have many agents that are chatting with each other to solve a particular task. And this has a lot of science fiction and make-believe going for it. In many cases, the multi-agents are just the single language model, but with different prompts. So for example, they have one language model and ask it in the prompt, you are the problem solver. And then the other language model, they ask, other agent would be the same language model, but in a different prompt. You are the reviewer. And then the problem solver solves the problem and the reviewer reviews it. But adopting different personas doesn't impart new fundamental capabilities. It just changes external behavior. And there's really no real success. Although it's always a dream that, there is some kind of emergent behavior that comes from agents communicating with each other. But so far, there hasn't been anything that has moved the needle. And then finally, the one that really is been, and now I think it's also getting more well known in the community at large. The futility of self-evaluation, asking an LLM to just check whether it is correct or wrong, so that if an LLM gets it wrong, then it can correct itself, and thus you can solve any problem you give it to it. There's a problem with that. There are many problems, but one problem that I can show you here is that LLMs exhibit sycophantic behavior, which means that there is a tendency for LLMs to please you. So for example, when you have something like this, I ask it a question, it gives the answer, it's the correct answer, but then I try to contradict it, or I ask, are you sure? And then it has this tendency to agree with me, even though it gives the answer the correct time, and then it gives the wrong answer. And there is a paper that has done a lot of work on this. GPT doesn't know it's wrong, where they compared many different techniques, including one where the LLM self-critiques. So asking the LLM to critique itself is just not is actually makes its performance worse than if you just asked it once. So coming soon to Hudson Labs. So we are actively working on bringing agentic features. So right now we are working on a V0.1 because, as I said, there are certain limitations that would prevent full-fledged agents from being feasible at any in the near future. But there are given all the things that we have talked about, there's definitely the time is right for a V0.1, which are working on right now. So for more specifics of that, look out for our next webinar, which we haven't announced yet, but we'll hopefully announce soon. Yeah. So that's it for the, and I'm looking forward to questions.
So if anyone has questions, please feel free to type in the chat. You can type anonymously to if you hit hosts and panelists, and we can chat through that, or feel free to post to everyone. I have also launched a poll. Yep. Please tell us whether or not you found this valuable. We'd love to hear your thoughts. It's very expensive to get to Suhas if you go through Tegas or Stream or any expert network. So now is a great time to ask his thoughts on the anything. Just give a quick minute for people to write things out. All right, so here's one, Suhas. If you were getting approached by an AI vendor tomorrow, say you're working in a big bank, what are some red flags you'd look for to avoid buying the wrong AI tool right now?
I think anything that promises a generalist solution, saying that, hey, this tool is, one size fits for all, works for everything. And I think it's also about the kind of questions that you can ask, maybe asking, how did you evaluate whether your solution works? Because that's the proof is in the pudding, right? Uh, and asking about evaluation, because this is the single biggest thing that is, I guess, plaguing most companies right now, like both the builders and the consumers, is how do you evaluate the systems that we have and that are available. And many companies that build do not have robust evaluation processes. So if they do not have a good answer for how do you evaluate your product, then I guess that's a major red flag.
Awesome. Another one in the Q&A here. Will these limitations get fixed in GPT-5 and beyond?
Yeah, that's a really good question. So I think GPT-5 will definitely make agents a lot more, or not just GPT-5, but any model that's coming out in the next few months are going to definitely move the needle. But as I said, there are some fundamental limitations that would always be the case. So we have seen this in other technologies like autonomous cars, for example, where it seems like we are almost there, but it takes a long time for some of the tricky issues to get resolved. And in this case, for example, as I mentioned, when we first created this data set, it was 7 out of 100. So that was ChatGPT or GPT 3.5 that was getting 7 out of 100. Today's best model gets 12 out of 100 on this test set. So 12 out of 100, and maybe GPT-5 will take us a little more, but I don't see it, taking significant leaps. So while there is definitely, improvements that we'll see in all of these, just like we have seen it in the last 2 years, I don't think it's, at least with the pace that we are seeing now, I don't think you will see a very substantial improvement. Although for the end user, it might look different because with better models, we can build better experiences. We can hide things, we can hide the limitations better. So I do expect more feasible agentic solutions coming in 2025.
And I think the natural question that comes out of that, and that we get asked by VCs all the time, is when GPT-5 gets better, GPT-6, etc., does that will we not we need application level
Yeah.
companies?
Yeah, so I guess we have seen that generalist models again are general, and we have seen in several different cases. So, for example, this case, that specific models will always have an edge, not just an edge, but a mile. And we see that, and full disclosure, we have the option to use OpenAI models in our products, but we use them for very, very limited cases. And the reason is not just cost, but it's the main reason is actually they don't work as well as finance specific models. So if our entire the Hudson Labs product was just built on OpenAI, you would see a much worse product than you are currently looking at.
So someone asked what our value proposition is, so I should clarify in case it wasn't already clear. This is not a product demo. Obviously, this is an AI technical talk. If you are interested in the Hudson Labs platform, I would be more than happy to walk anyone here through a demo of the product. And we also do have a trial period for all institutional users. So another question for you, Suhas. Can you talk a little bit about leveraging real-time data? So the question is, can LLMs consume up-to-date data
Yes.
in real time? And does that work? Out of
Yes.
memory reasoning.
Yes. So by real-time data, I'm assuming data that is generated at a particular point, and
Like
if
what we do.
LLMs,
Yeah. Yeah.
and LLMs have access to it. Yes.
Yeah.
So you can um, plug the data that you have to the LLM and make it available to the LLM. Yes. So the LLM will not be trained on it, but it can use it as an external knowledge base. So that is the RAG framework, which is getting more and more mainstream as of this year. However, for in the RAG case, we already know which data that we need to look up because you know um, the model is already given a clue on what data to refer to. The 2025 hopefully would be where we don't need to tell the model itself figures out what data to integrate, what data to look up, and so on. Yeah.
And just to follow up on that, the discussion we had about, can a model reason when it hasn't been trained on the data already is a core part of RAG actually working, or retrieval augmented generation working. So a two-part question for you here. First, benchmarking, Suhas. What are the best benchmarking tools for financial LLMs? Is there anything good out there? Is there anything you would trust?
Yeah, that's a good question. So right now, the best practice for benchmarking is to develop your own internal benchmarking data sets. Or so that combined with pure vibes. And that might sound a little cliche, but pure vibes is better than some of the benchmarking data sets out there. That being said, I remember, and Chris, maybe you remember the name because I forgot it.
Patronus AI.
Yeah, Petronas AI has a benchmarking data set. I think it's a paid solution, so you need to pay them X amount in order to get access to the data set. And but at least at first glance, like I had a quick look at it some time ago. It looked decent. So that could be one of them. But I think the best practice, and even though this might be a frustrating answer, but the best practice is to develop something internally, to what matters to you, and never reveal it. So the same thing for us. So we developed our own internal benchmarks and we never reveal it. Like I make my talks boring by giving the exact same examples again and again because these are the only examples that I've revealed in public. Everything else remains private. The reason is that if you put it out in public anywhere, the next time the language GPT-5 is being trained, it's trained on that, and you don't know whether it's memorizing or not. So keep an internal benchmark, and also the more you use the model, the more you get vibes based signals.
And I think this is probably going to be a nuanced answer, but how much does it cost to train a useful finance specific LLM?
Yeah. So it it depends on the size of the model, of course. So there are small models, there are bigger models. So if you build a smaller model, you can augment it with bigger models, and thus, you don't have to depend on the small model, just the smaller model. If you want a bigger model, just like how Bloomberg GPT, for example, trained the 40 billion parameter model, if I recall correctly, it would take a few $1 million just on infrastructure costs alone. So that doesn't include, the people needed to train it. Just infrastructure costs alone, it could take several million. But you could also build a smaller one for a few 100,000 or so as I said, it depends on the size, but the make to make something usable from scratch, I would say um, at least six-figure dollars is uh, just for infrastructure. Again, the word usable comes into play because you can train a very small model, for $1,000, but it won't really make any difference, and it would be worse than anything else
But
available.
I think one thing to note here is what is useful is widely different uh, depending on the use case, right? So for certain more generic uh, finance tasks, you could be using a generalist model with, zero shot and be fine, or have minimal fine training. So it fine tuning. It really depends on the complexity of the task. Would you say
Yeah,
that's
yeah.
true to us?
Yeah, exactly. And the numbers that I mentioned are when you are pre-training from scratch. But in most cases, you don't need to pre-train from scratch. You can take a existing model and then fine-tune it for your purposes. So, for example, I think there's one, I don't remember the name, but it's Finbert, which is available since 2020 or something. And it was fine-tuned, I think, probably with a budget of less than $2,000. Um, and in today's money and with like today's, because things were a little more expensive back in the day, in today's money, it would be probably less than $500 for the same compute. Um, and I think uh, same compute and infrastructure. And that solves the task of financial sentiment analysis, whether it is, the best, that's a debatable question, and whether it actually solves people's task is a debatable question. But for specific tasks for fine tuning, it could be a 1 day project if you have the right technical resources, and it could cost less than $1,000, for example. Yeah.
So we only have 1 minute left. So thank you everyone for coming. But I do want to get in one last question for you, Suhas, which is, agentic AI is coming. Is it going to replace equity analysts and PMs?
um, so I guess it's we agentic uh, uh, a variant of agentic AI or a variant of a copilot for financial analysts already exists, and it exists for programmers called GitHub Copilot and GitHub Copilot and other tools. So what they have done, and I have noticed this, is that they have made very experienced programmers even more productive. But they have not made junior programmers a lot more productive. So that means it has increased the you know the difference between a junior and a senior programmer by a lot, and we are already seeing this in the industry. Similarly, when we have agents, when we have a copilot buddy for a financial analyst, I don't know if you can take it like 100% parallel, but I do think that something similar will happen. Has it affected the number of programming jobs, like the GitHub Copilot, etc.? I mean, the overall, we don't know, but it has made people who are experienced, who are reasonably experienced, a lot more productive, has made their jobs a lot more enjoyable. But on the flip side, it has made entering the field a little harder, because now the barrier is higher. Uh, I don't know that if that part is transferable to finance. Maybe not, but yeah, just
Uh,
sharing my experience from the other side.
yeah. I mean, my perspective on that is that, there's, the job of an equity analyst is to beat the market. So, uh, it's always you're going to be using the tools at your disposal and getting an edge. So we're likely not going to be automating away anyone who's truly brilliant. But I just